Okay. Welcome, guys, to the last session, and we have definitely saved the best for last. And I think I've been strategically planted here, just for the management to tell me that you actually don't know anything. So just please speak to him for some time. Just get back to your senses. Okay. So it's actually happened. So I'm really humbled, and I'm actually very nervous right now in terms of what I actually need to do. But I think we're prepped. So I'll talk less and I'll allow Saad to talk. So one of the things that we wanted to discuss is what I found out is that he can explain technology so well and so simply that in the last 2 hours I've actually learned what is artificial intelligence, what is blockchain, and what is cryptography, and most importantly, how all the three of them are really linked together. So I'll just allow him to explain to us. Maybe Saad, we can start with uh, like how you explained to me the evolution of and the difference. Firstly, the difference between artificial intelligence and machine learning. So maybe we can start with that, and also the evolution and the winter, etc., that you told me about.
Okay. So AI started out in the 80s actually. And what they used to do back then was basically program via code what would you do in certain situations. So these systems are good, but they had one problem. The moment you told it something it wasn't trained for, it would just show up on the data and not be able to do anything. So then there was a winter of AI, and then recently there was a revival because now people were thinking, what can we do in data? So instead of coding all the edge cases, we could actually use data instead of code. So this started mostly after all these internet companies wanted to deliver a better user experience. So for example, Google wanted to do better search results and things like that. So they started using data to train models to predict various things.
So you told me about page ranking and how page ranking could be defrauded and why they got into intelligent AI.
Yeah, so one interesting application is Google. So, as you know, Google allows you to search the web for various things. What was there before Google was something called directories. So you had to, so they used to categorize based on what they thought was the correct choice. They used to categorize websites into categories, and you would browse the directory and find out the website you wanted. Google came with the idea instead of looking for the content and going, we are looking for content, right? So what we usually do is search. So they thought, what if we could search the web? So they could, of course, crawl the web and generate a list of data. But how do I know which website to recommend to you? Well, before they use an algorithm called PageRank, which is based on a model of a random surfer. So I would enter the web at one web page, and then I would keep moving around in this. You could think of the web as a directed graph. So this website links to all these websites and so on and so forth. And more specifically, pages link to pages. So now the surfer will start with one page and then he'll eventually go to all the other pages. And the probability of him going to a page depends on the number of incoming links. So they would sort roughly by that number. But of course, that's easily you can easily do some stuff to make your page rank higher, like put lots of links. So what they start doing is they start using artificial intelligence instead. So they would actually go and read the page. Is there something interesting in the page? So not only the links, what's in the content. So is the content filled with repetitive words and those kind of things. So that way they were able to give a dramatically better search results.
Okay, interesting. So how is artificial intelligence different from machine learning, or is it the same thing?
Artificial intelligence is simply intelligence. That is the machine thinking about being intelligent, which is, and machine learning is more about can you make the machine learn? So both of them can go hand in hand, but they're not necessarily the same.
So what you're saying is intelligent machine is somebody you've fed in some code into, but
Yeah,
machine learning is the machine learning and adapting the
yeah.
code by itself.
So
Interesting.
code driven versus data driven.
Okay. So when we talk about artificial intelligence, what are some of the biggest applications that you're seeing right now, and how does it work? I think language interpretation was something that you spoke about.
Yeah, so there are various things you can do. For example, language interpretation, as you said. So English is a very ambiguous language. We can parse it, but if you wanted a computer to parse it, it's a lot more difficult. Uh, so using AI, you can stochastic models in general. It's easier to parse English. So, for example, all these personal assistants, they often use artificial intelligence and machine learning to deliver you results that you want, because your preferences are naturally different from everyone else's preferences. And if you had to code your preferences, it would be very difficult. And data driven architectures really are more driven towards these sort of applications.
Okay, interesting. So, where are the other applications of machine learning, artificial intelligence that you are going to see in the future and maybe right now?
A big thing is actually recommendation. So if you're seeing movie recommendations, Facebook friend recommendations, amongst other things, they are all based on what other people did. So let's they look at who you're already. For example, let's take movie recommendation. They see the machine sees everyone else and sees what movie they have watched, so naturally, it'll identify you as a part of a cluster that watches similar movies. And let's say somebody's watched similar movies to you, a lot of people, and then they watch some other movies that you have not watched. So then the system says, "Are you interested in watching this movie because other people like you watched it?" If you say no, that you are not interested, then the machine can learn that you don't like these types of things and add that. So next time when it generates recommendations, it'll take that into account. Um, this is where machine learning shines, because it'll be very difficult to code in a list of movies to recommend it, because it varies a lot between person to person.
Okay, interesting. And maybe we'll talk about something that you are doing more currently. So, what are some of the projects that you're working on right now?
Various ones. So I'm working on one project to teach both programming and the entire computer science stack to students.
Can you explain a little more how you're doing it and what you're doing at the back end?
So basically, as you know, learning programming is going to be essential skill soon. And how would we teach people how to program? Well, I was mostly going with the fact that we could teach people the entire stack. So if you look at computer science, it's mostly abstractions. You are coding in some software programming language, which probably compiles your code either to assembly or interprets it. And then there's a CPU, and then below the CPU are some more abstractions that are used to build it. So by implementing all the layers of the stack, you might be able to understand computer science in a way that would be difficult otherwise. So in reality, while you would not build the stack again because it's a waste of time, sometimes it is useful to know how the stack works.
So, you mean to say I can even go to the chip level and
Yeah.
simulate it? How
So you
easy?
would build from NAND gates. You'd build more complicated gates. Then you would build things like ALUs to compute various functions, and then on top of that, you would build a complete CPU and then write programs for that CPU.
Interesting. So, I would imagine what you do at the back end to simulate these NAND gates, etc., would be complex. Do you use standard software like MATLAB to simulate it, or?
The there are a few software. There are a lot actually for simulating these hardware designs. So that's what. So Verilog and the entire ecosystem that goes on behind it. But I found it's a little complicated for most people. So I'm mostly implementing my own HDL to describe. You can always the skills learned can be used in any language, of course.
Okay. So you just found the out of the box things too complicated, so you made your own stuff.
Yeah, they're
Cool.
powerful but complicated.
So it's largely open source is what you use,
Yeah.
right? So guys, we've been talking about the open source disrupting. I think this is a very clear case of that happening. Good. So and also you spoke about one of the projects that you're doing for ISC, and also sorry the Mars rover program. Do you want to touch upon that?
Yeah, Team Indus. So I'm also a member of Team Indus. So we are a company working on sending a rover to the moon. So we are the only Indian team in the Google Lunar Xprize. The Google Lunar Xprize is a competition in which a private company must land a rover on the moon, drive 500 meters, and send back HD video. We are actually one of the top three teams in the competition.
Interesting. So what is your role in that? What are you helping the team with?
So I'm working on the command and data handling team. So basically, all the software and these hardware required to run all the commands and
Interesting.
interface with all the components of the spacecraft.
Good, good. So one of the things that I have to ask you, and this is by popular demand, is, and honestly, I did not know till you told me about it. So how many of you guys really understand what blockchain is? What is Bitcoin? Bitcoin theft? Okay, so there are a few. There are a few people. Maybe you can be patient with us. So Saad, can you just explain what is blockchain? How did it develop, and what we are going to do with that now?
So the blockchain is pretty simple. It's just a distributed ledger. So if you've ever seen, for those of you who haven't seen a ledger, it's just it's like it stores how much money has come in. So basically transactions, money that's come in and come out. So the blockchain was originally invented as part of Bitcoin, which is a cryptocurrency. So they wanted to decentralize payment. And how would you do that? Of course, you need a ledger for payment. So the blockchain is simply a ledger, but it's special. Everyone has a ledger, unlike the conventional system in which only the bank has a ledger. And then there comes a question. So now everyone has a ledger, and once you have a ledger, it's pretty easy to do most things. But who gets to add to the ledger? So that's a question, because if you let anyone add to the ledger, then there's nothing stopping someone from saying, I actually have more money than I am supposed to have. So you solve that problem by using something called proof of work. So it is basically this complicated puzzle of sorts, and it's a random puzzle. It's like you have to give compute power to run a lottery, basically, in which the more compute power you have, the more likely you are to mine a new block. And a block contains transactions. We do not put individual transactions because that will be too inefficient. um, and a block references the previous block, creating the blockchain. Within each block there is all the transactions. So now the blockchain is really cool, because now through this system we have created, in essence, a distributed ledger that everyone can have. Anyone can add things to it as long as they're valid, of course. And with this we can do some really interesting applications. So for example, first of all, payment becomes easier. And then but what they the more interesting applications stem from the fact that we don't use money itself, but we use money to buy other things. So how can we buy other things without having to trust some third party? So, for example, Bitcoin is a cryptographic protocol, so there's no legal. So it's basically replacing legal basis. So instead of a contract or something, you use cryptographic code. So you replace legal basis with a cryptographic one. And how would you? But then, so Bitcoin, once you pay someone, you cannot take it back like you could with a credit card. So how would you? So for example, if you've ever bought something, you generally have some protection. If you don't get what you wanted, and you can convince the credit card company, so you'll generally get your money back. But in Bitcoin, that's not possible, because there is no single person who can change the blockchain. In fact, it is impossible to change the blockchain once you've added something to it. So it's impossible to reverse a transaction. So what you do is you use multi-signature addresses. So they're Bitcoins, the blockchain equivalent of a joint bank account. So instead of one person owning um, the whole amount of money, multiple people own it. So you can use things like two of three, in which two people need to authorize a transaction and three people own the account. So now some trusted third party Now, this trusted third party can actually be random. Any trusted third party will work. So you don't have to use the one. You don't have to use the credit. For example, in the credit card system, you can only use Visa as a trusted third party. So now, if I want to buy something, I put the money in a multi-signature address. An address is kind of like an account, and then I send the money, and the but the seller cannot deduct the money, nor can I. Two people have to authorize. So in case everything is okay, I and the seller can authorize, and the seller will get his money. If something is not okay, then the third party and the buyer can say not something is not okay and take the money back.
Interesting. Okay. So, so one of the questions that I always had is, you keep reading all the bad things about Bitcoin, as in somebody stole Bitcoin, somebody defrauded somebody of millions of Bitcoins. How does that happen, and how is it that being checked? And that you can take that to the next thing that you're currently reading on, that's cryptography and how it's linked. So firstly, you can explain what actually is Bitcoin theft and how it happens.
So Bitcoin is a cryptography protocol, and it's almost impossible to do something to Bitcoin, hack it. So what happens is, once you pay to someone, it's irreversible. You cannot take it back. So often there are cases of people. So some people don't understand that, and they might accidentally pay to somebody who says. So, for example, exchanges. Bitcoin has exchanges where you can exchange bitcoins for USD. So somebody might pay to an exchange that says, "Hey, come to us. We'll give you 10% less." But then what happens is they don't give you 10% less. They run away with your money. And since Bitcoin is, and this is by design, once you pay, you cannot reverse, because then there's no legal basis, right? So who is going to say, when can I take the reverse the transaction? So if you want to be safe, you'll have to use something like the escrow system I mentioned, in which are two or three. Most Bitcoin marketplaces have this sort of setup. So Open Bazaar, for example, they have moderators. So if you have ever been to a forum or something, you might know about moderators. They are people who are inherently trusted, and they will mediate the transaction. And there's another case of fraud in Bitcoin is wallets. So lots of people. So whenever you deposit Bitcoin, I always recommend you to use your own wallet instead of somebody else's wallet service, because unless of course the wallet service is big enough that you can trust them, because there are a lot of cases of people saying we have Bitcoin wallets, and when you put the money in there, you realize it's gone.
Interesting. So it's not the technology. Technology is good. It's just the people who don't understand it and think it's actual fungible money and get themselves defrauded
Yeah.
at the end of the day. And you were also explaining how cryptography plays a key role in within the Bitcoin and trying to make it safer in the whole blockchain concept.
So now Bitcoin, blockchain in general, gives you a way to pay, but cryptography gives some neat constructs on top of it that we can use to do more complicated things. So, for example, if you ever use these popular aggregators such as Uber, Airbnb, and all those, where they either rent or sell you something, um, how do you know? There, the aggregator acts as a mediator to make sure you get what you paid for. How would you do that without an aggregator? So with blockchain, you could have things like smart locks. So this is basically connecting IoT and blockchain. So in my house, I might have a smart lock that listens to a blockchain. So somebody can pay money through the blockchain and simultaneously get access to the lock for, let's say, 4 hours or something. So whenever they come, they using public key cryptography, their phone will say, "Hey, I am this guy, and I'm authorized. Can you open the door?" The door will ask, um, "I give you this random number. Sign it with your key to make sure, so I know it's actually you." And digital signature is just like normal signature, difficult to make but easy to verify. And now you have a way of easily renting, selling, and buying stuff. This sounds neat, and it is, but it's even neater when you consider that this can be chained with other things. So, have you ever seen collateral loans, in which you loan like a car loan or a house loan? How could you do that on a blockchain? Well, you could do a transaction in which I'll give some money, and if I'm not paid back within 30 days, I get the car or I get the house. So now, without anyone knowing, so you don't have to trust the other person. So now anyone on the any stranger can loan you some money, knowing that if you default, you'll get the thing. So now it's totally possible to loan between two completely unknown people. So you could just randomly loan even on the internet.
Interesting. So, so do you think the Visas, Mastercards, and the banks know about blockchain? Because if it's actually implemented, this is like extremely disruptive. That's what I realize right now.
They're actually lots of banks are actually interested in using blockchain to help their own business, private blockchains. So how many of you have tried international wire transfer and got their money some swallowed at some point in the process? Okay, so what basically happens is there are lots of banks in a chain, and between each bank, there's some bank in the chain might forget the money, or some they might make an incorrect data entry, and your money goes down. So your bank might not even know. They don't know what happens to the money after it leaves them. So they just try to. So when you tell them to, they actually know. They'll then go and check and find out what happened. So you have to call each bank in the row, and then only will they know where the money got lost, and then they'll say, "Man, some money got lost here," and then it'll go on. So what you could do with a private blockchain is all the banks could have a private blockchain, and the money would be there. So now it's very easy for auditability purposes, right? The blockchain is public. So Bitcoin is based on the fact that identities are private and transactions are public, while the bank system is based on the fact that your identities are private and the identities are public and the transactions are private. So this way, it has auditability. So now the banks can see something went wrong here. So they can immediately go and find out what went wrong.
Interesting. So the other thing that you were talking about is cryptography, and one of the things that was interesting to us is recently how Apple stood up and said we will not allow anybody to get into our phone, etc. But what I actually didn't understand is what was it an encryption that they were doing, or what is it that they were not allowing somebody to do, and why was it so complex for FBI to break into a basically a simple phone, or was it actually that complex?
So, if any of you have used an iPhone, most new ones come with what's called full disk encryption. There are no disks anymore, but it's still called full disk encryption. So all the stuff you store on your memory card is encrypted with a key, and that key is derived from your PIN code. And if you use fingerprint, it stores your fingerprint and the key in a special secure RAM, which that's why whenever your iPhone gets powered off for a long time, it forgets your Touch ID and you need to use your PIN code. So what basically happened is, so this PIN code can be brute forced, but you cannot do it on the iPhone itself, because if you do it as you know, if you type in an incorrect PIN too many times, it will simply delete everything on the device. So technically, if Apple does not know your key, Apple cannot compromise your key, because your key never touches Apple. So what could happen is, what the FBI wanted was, they wanted the code signing key, so they could load an app on update onto the phone that would allow them to brute force without that three tries limit. You could also do it with desoldering the memory chip, but I think they didn't want to take the risk of it breaking.
So how would you desolder the memory chip?
Generally, this you just put in an oven literally and pop things.
Okay, interesting. So, what do you think they finally did? So they removed it. You were talking about some machine that they could actually get into.
You would just remove the chip, then you could read it out, and you could just brute force it. So there are machines to do that. So you had these. I believe Apple uses AES. So AES is easy to implement in hardware. So they probably implement a lot of those machines and kept looping through all the pin codes, like how you'd break a combination lock.
Interesting. So I don't know what Apple guys were doing. They could have just asked him. FBI could have just called up Parvez, who's Saad's dad, and asked him to just do a small project for half a day or something. So good, good. So it's good to know that our data is secure, but not as secure as Apple makes it out to be. Uh, so although we are out of time, I don't mind exceeding it. Do people have some questions? And I would suggest that we keep the questions at technology level and not try to ask the future of XYZ or future of India and those kind of things. Yeah.
I don't have any technological question because it is overwhelming for me to understand what is the, even if it is simple language. Yeah, what is your age? Which school you go? Do you have any book written on what you are saying? And do you think that you are spoiling your small age by not playing and doing something which is overwhelming for us? Yeah.
Those are overwhelming questions.
I'm thoroughly impressed. I mean, congratulations, and my best wishes.
Thank you.
So I think I know which school he goes to.
Yeah, I'm 14 and I'm mostly homeschooled. Do I do go to Clarence High School? Fraser Town.
Now it's getting into scary detail. Anybody has questions?
No, not really.
Okay. One or two final questions, specific technology questions? No? Okay. The back, one question.
Saad, just curious about how do you stay curious as far as technology goes, and how do you keep yourself updated on blockchain and the things that are happening around technology?
If I were to rephrase it, would you suggest some kind of reading material that you use to keep yourself updated, or is it just random?
Basically, most cryptocurrencies they change a lot. So if you want to learn more about Bitcoin, one thing would be first the original paper, then the Bitcoin enhancement protocols, which is a GitHub repository, and then the source code, because that's always correct.
Okay, so all you guys reading Flipboard and all the different blogs that people write, sorry, that's of no use. So you need to get down to the source code. Great. I think, Saad, thank you so much for joining us. It's a great pleasure for us. And I think after 2 days of technology and people bantering, we finally understood something. Thank you so much.
Thank you.
Thank you, Sidhant, and thank you, Saad. I think we truly saved the best for last.